Welcome to grade 9 CBSE Maths class. I am Sudhi here. Today we are going to discuss about chapter number 2, polynomials. So from the chapter itself, we want to discuss about more about polynomials, like that, some equations, expressions, all things. So what is a polynomial? First of all, we want to know that what is a polynomial. Polynomials are just expression, but writing that expression there will be some conditions. So by examples I will quote or some examples I will show that what all the things are called polynomials. So first of all, so I write the expression x cube plus x square plus 2x plus 5. Is that a polynomial? Yes, this is a polynomial. How will you say that this is a polynomial? Okay, then I will write another one. Root x, is that a polynomial? It's not a polynomial. So why, we will discuss. This is not a polynomial. Not. Then x cube, is that a polynomial? Yes, this is a polynomial. What about x? Is that a polynomial? Yes. What about 2? 2 is a polynomial? Yes, 2 is a polynomial. What about 1 by x? 1 by x is not a polynomial. So why we have to say that root x and 1 by x are not polynomials? How will you expand root x? Root x we can write as x raised to 1 by 2. What about the power? So this is the exponential and this is termed as power. And what about the power? The exponential term or the power is 1 by 2. It is a fraction. So if the power of the number, power of the variable, if the power of the variable is not a whole number, if the power of the variable is not a whole number, then that expression is not a polynomial. That's why root x is not a polynomial. Why root x is not a polynomial? Because root x can be written in the form x raised to 1 by 2. What about the exponential? Exponential is 1 by 2. That is simply means that the power is 1 by 2, which indicates that that is not a whole number. So if the whole number is, if the expression consists of a if the expression consists of an exponential and that power is not a whole number, then that expression is not a polynomial. So this is not a polynomial. So what about 1 by x? 1 by x can be written in the format x raised to minus 1. Right? When the x in the denominator tends to the numerator or comes up to the numerator, then it can be written in the format x raised to minus 1. So this is not a whole number. This is minus 1. So the power is minus 1. So the power consists of fraction, the power consists of minus numbers, then that is not considered as a polynomial. So this is also not a polynomial. So that's all about the polynomial. Simple thing is that the exponential term or the power term of the variable is completely a whole number, then that term is said to be a polynomial. So why 2 is a polynomial? Because 2 can be written in the format 2x raised to 0. As we know that any quantity raised to 0 is 1. Therefore 2 into 1 is 2. So 2 can be written in the format 2x raised to 0. 0 is a whole number. Therefore x raised to 0 is 1, we know, and we can express 2 in the format 2x raised to 0. Therefore x raised to 0, 0 is a whole number. Therefore 2 is also considered as a polynomial. So whenever you checking whether the term is a polynomial or not, you first check the power. When the power is a whole number, then that is a polynomial. So I will just write some examples of polynomial. I will just write some examples of polynomial. So x square plus 2x plus 3 is a polynomial. Also one more thing is that I just forgot to tell that thing. So a polynomial is represented by either p of x, this can be read as p of x, or q of x, or r of x, like that. This is the general format to represent a polynomial. Most of the time p of x is used. This is p of x. So p of x is equal to, for example of a polynomial, p of x is equal to x square plus 2x plus 3. This is a polynomial which consists of how many terms? 3 terms and one variable. 3 terms and one variable. There will be 3 terms. First term is x square, second term is 2x, third term is 3. And how many variables are there? Only one variable, that is x. So it consists of 3 terms and one variable. What is the highest power of the variable? The highest power of the variable is 2. So there will be 2 here. There will be 2x. The variable of this x is 1. The variable of x is 2. Sorry, the power of x is 2. The power of x is here 1. That means the variable has a power 2 here. The variable has a power 1 here. That simply means that the highest power of the variable is 2. So just include it in your mind such that the highest power of the variable is 2. So another way of polynomial is p of x is equal to 6x raised to 5 plus 4x square plus 2x plus 3 is also a polynomial. Consists of how many variable? Only one variable. That is x is the variable here. But how many times? There will be 4 times. 1, 2, 3, 4. What is the highest power of the variable here? The highest power of the variable is 5. Because here 2 is x is a variable but the power is 2. X is a variable, the power is 1. X is a variable but the power is 5. So the highest power here is 5. What about p of y? There is another polynomial in terms of y, that is 3y plus 2. This is also a polynomial. How many times? 2 times. What is the variable here? Y is the variable here. That means only one variable is here. What is the power of y? Power of y is 1 and the highest power is also 1 because there is only one variable here and 2 times. What about p of y? Another one is 3x, not 3x cube, 3y cube. It is expressed in terms of y. So p of y is equal to 3y cube. What is the power of y here? 3. Is this a polynomial? Yes, this is a polynomial. And how many times are there? Only one time is there. Only one variable is there also. That is y is also a y is a variable. There will be only one variable. So 3y cube is a polynomial. The highest power of the variable is 3. So looking into the matter, how many times are here? There will be 3 times. How many times are here? There will be 4 times. How many times? 2 times. How many times? 1 time. A polynomial with only one time is called a polynomial with only one time is called a monomial. A polynomial with only one time is called a monomial. A polynomial with a two time is called a binomial. A polynomial with a two time is called a binomial. So this is only a one time one time. This consists of only one time. So this is called a monomial. This consists of two times. This is called a binomial. This is called a polynomial consists of 3 times. Oh, polynomial consists of 3 times called a trinomial. Trinomial. Polynomial consists of 3 times is called a trinomial. What is a polynomial consists of 4 times is called a tetranomial. So generally all these terms are called polynomials. Polynomials. All these terms are called polynomials. Here polynomial consists of only one term or otherwise two term or otherwise three term or otherwise four term, like that. So a polynomial consists of only one term is called a monomial, consists of two term is called a binomial, consists of three term is called a trinomial, consists of four term is called a tetranomial, like that. There will be a lot of terms are there, and generally all these terms are considered as polynomials. All these terms are considered as polynomials. Now we are going to discuss about the degree of a polynomial. How will you find out the degree of a polynomial? The highest power of the variable in a polynomial is called its degree. The highest power of the variable in a polynomial is called its degree. What about here? Already we say that this polynomial consists of 3 terms and only one variable, that is x. What is the highest power here? highest power here is 2. So here the degree of the polynomial is 2 because the highest power of the variable is 2. Here I just write the polynomial here. P of x is equal to x square plus 2x plus 3. Here the variable is, what is the variable? Variable is x. Now here 2x, what is the power of that x? The power of x is 1. What is the power of x here? Power of x is 2 here. So the highest power is 2. So the degree of the polynomial here is 2. The highest power of the variable. Right. 6x raised to 5 plus 4x square plus 2x plus 3. Here the power of x is 1. Here the power of x is 2. Here the power of x is 5. So the highest power is 5. So the degree of the polynomial is 5. Here 3y plus 2. Here y raised to 0. If we consider y raised to 0, here the power of y is equal to 0, but here the power of y is equal to 1. So the degree of the polynomial is 1. Here only one time, the power is 3, the degree of the polynomial is 3. How will you find the degree from 3x raised to 4 plus 3x square plus 8? The degree is 4 because the highest power of the variable is 4. Here 2, here 1, 2, here the power is 4. Therefore, the highest power is considered as the degree. So, the degree of the polynomial is 4. What about 9y raised to 5 plus 9y plus 8? Here the power of y is 1. Here the power of y is 5. So the highest power is 5 and the highest power is considered as the degree. Therefore, the degree of the polynomial here is 5. So that's all about the degree of a polynomial. Degree of a polynomial. Next, we are moving to find out the linear polynomial. That means linear polynomial, quadratic polynomial, like that. We are moving like that. That is first degree polynomial, second degree polynomial, third degree polynomial, like that. So here I write an equation. P of x is equal to x cube plus 3x square plus 2. So from this equation, it is clear that the degree of the polynomial is 3. So it's a third degree polynomial. It's a third degree polynomial. So next one is P of y is equal to y square plus 2y plus 3. What about the degree of the polynomial here? The degree of the polynomial is 2. That means it is a second degree polynomial. It's a second degree polynomial, or otherwise we have to say that it's a quadratic equation. Second degree polynomial is called a quadratic equation. So next one is P of x is equal to x plus 3. So the degree of the polynomial is 1 because the power of x is 1. So the degree of the polynomial is 1, which is called a linear polynomial, or otherwise called a first degree polynomial. So first degree polynomial, second degree polynomial, third degree polynomial. How will you identify a first degree polynomial, second degree polynomial and third degree polynomial? If you have an equation with you and that is a polynomial, first of all you identify that it is a polynomial or not. If you identify that is a polynomial, you just find out the degree of that polynomial. With respect to that degree, we can conclude that is it a first degree polynomial or second degree polynomial or third degree polynomial. We can solve all the polynomials regarding with respect to the equations. So this is a first degree polynomial because the degree is 1, because the highest power of the variable given is 1. That is called the degree. The degree of the polynomial is 1. Therefore, this is a first degree polynomial, or otherwise called a linear polynomial. Here the first, here P of y is equal to y square plus 2y plus 3, which means that the degree of the polynomial is 2. That means that this is a second degree polynomial, or otherwise we have to say that it is a quadratic equation. Then this one, the degree of the polynomial is 3 because the variable consists of the highest power 3. Therefore, this is a third degree polynomial. So far, therefore, there will be fourth degree polynomial, fifth degree polynomial, like that. So this is first degree, second degree and third degree polynomial. What is the coefficient of x cube here? Coefficient of x cube is 1. What about the coefficient of x square? 3 and 2 is a constant. What is the coefficient of y square here? Y square, the coefficient is 1. Y, the coefficient is 2 and 3 is a constant. What is the coefficient of x here? The coefficient of x is 1 and 3 is a constant. And here, if the equation like this, p of x is equal to 3x square plus 2x plus 8. What about the coefficient of x square here? The coefficient of x square is 3. The coefficient of x is 2 and 8 is a constant. P of x is equal to 3x cube plus 2x square plus x plus 8. So what about the coefficient of x cube here? The coefficient of x cube is 3. The coefficient of x square is 2. The coefficient of x is 1 and 8 is a constant. So that's all about the primary part of the polynomial. So here in the first introductory part, we want to know about, or we already know about, how to find the degree of a polynomial. What are monomial, what are binomial, what are trinomial? How will you identify a first degree polynomial, second degree polynomial and a third degree polynomial? This all depends upon the first degree, second degree and third degree, all depends upon the highest power of the variable in a equation. So that's all about the degree of a polynomial, and first degree polynomial, second degree polynomial and third degree polynomial. So next we want to find out how to find the value of a polynomial. So we want to find out the value of a polynomial. So how will you find out the value? So first of all, I will just write a polynomial such that p of x is equal to 3x square plus 2x minus 5. So find p of 1. How will you find p of 1? So here the variable is x. So in the polynomial, the variable is x. So we want to find out p of 1. How will you find p of 1? So in the place of x, we will give the value of 1. Then we got the value of p of 1. Therefore, p of 1 equal. P of 1 equal. So p of x is equal to this much. So p of 1 equal 3 into, in place of x, we use 1. 1 square plus 2 into 1 minus, there will be no x, so 5. So 3 into 1 square is 3 plus 2 into 1 is 2 minus 5. That is 3 plus 2 is 5. 5 minus 5, that is equal to 0. Therefore, p of 1 is equal to 0 here. So another one, if p of y equal 3y cube minus 2y square plus y minus 10. Find p of 2. How will you find p of 2? So here the polynomial consists of a variable y. So in place of y, we will give 2. So how will you find p of 2? P of 2 is equal to 3 into, in place of y, we will give 2. 2 cube minus 2 into, in place of y, there will be 2. 2 square plus y2 minus 10. So 3 into, what about 2 cube? 2 cube is 8 minus 2 into, what about 2 square? 4 plus 2 minus 10. What about 3 into 8? 24 minus 2 into 4 square is 16, 32 plus 2 minus 10. 24 minus 32 is minus 8 plus 2 minus 10. So the value is minus 8 plus 2 minus 10. So minus 18 plus 2, that is equal to minus 16. Minus 16. So the value is minus 16. So how will you find p of 2 from this equation? You just place 2 in the place of y. So you replace y with 2. then you got the value of p of 2. So this is the method of calculating the value of a polynomial. So from these two examples, it is clear that how will you find the value of a polynomial. So we are doing some more examples. Okay, so the first example is we want to find out the value of p of x is equal to p of x equal 5x square minus 3x plus 7 at x is equal to 1. If a problem arises such that you have to find out the value of p of x at x is equal to 1, that means that you have to find the value of p of 1. P of 1 equal, so at x is equal to 1, in place of x there will be 1. So 5 into, in terms of, in place of x there will be 1 square minus 3 into 1 plus 7. That is 5 into 1 square. 1 square is 1. 5 minus 3 plus 7. That is 12 minus 3. That is equal to 9. So this is the answer of P of y. How will you find out the value? That is P of y. Given that the second problem is, this is the second problem. Second problem is given in terms of y. Therefore, it is not P of x. It is P of y equal 3y cube plus 4y minus root 11, and you have to find out the value at y is equal to 2. You have to find out the value at y is equal to 2. So you have to place 2 in place of y. So p of 2 equal 3 into 2 cube plus 4 into 2 minus root 11. What about 3 into 2 cube is 8. 3 into 8 plus 4 into 2 is 8 minus root 11. That is equal to 24 plus 8 minus root 11. That is equal to 24 plus 8, 32. 32 minus root 11. This is the answer. So how will you find the value? P of t. The third problem is P of t equal 4t raised to 4 plus 5t cube, 5t cube minus t square plus 6 had t is equal to a. So you want to find out not p of 1, not p of 2, not p of 3. You have to find out p of a. Replace t and place a. So 4 into, in place of t there will be a raised to 4 plus 5 into a raised to 3 minus a square plus 6. That is 4a raised to 4 plus 5a cube minus a square plus 6. So this is the answer. So this is why we will find out the value of a polynomial. Then now moving to the next topic called zeros of a polynomial. How will you find, or what about the topic zeros of a polynomial? If we have a polynomial and for some values, if the polynomial tends to 0, then that is the zeros of a polynomial. We have to check whether 1, 2 problems like that. So given p of x is equal to x plus 2 and check minus 2 is zeros of the given polynomial. Given polynomial. Okay. So check minus 2. So p of x is equal to x plus 2. Okay. P of x is equal to x plus 2. Then we want to find out p of minus 2. P of minus 2 equal, in place of x we will give minus 2 plus here 2. Minus 2 plus 2 is 0. That means then P of x is equal to x plus 2. When we given the value of minus 2 in place of x, the polynomial tends to 0. That means that this is the zeros of the polynomial. So minus 2 is a 0 of the polynomial. When we give minus 2, the polynomial tends to, the value of the polynomial tends to 0. What about plus 2? We have to check that P of x equal x plus 2. Then P of 2 equal, in place of x there will be 2, 2 plus 2, that is equal to 4. That means which is not a 0, which is not given the value such that it is 4, that means it is not a 0, that means it is not the 0th value of the polynomial, so it is not the 0 of the polynomial. So here minus 2 is a 0 of the polynomial, which means that whenever we will give minus 2 to this value, that means in place of x we will give minus 2, the value of the polynomial tends to 0, that means this is the zeros of the polynomial, this is not the 0. So again we want to check one more thing. So the next one is x square minus 2x. X square minus 2x. So at 2 and 0. First of all, P of x is equal to x square minus 2x. We want to find out the value of P of 2. P of 2 equal, in place of x we will give 2. 2 square minus 2 into, in place of x 2. 2 square is 4, minus 2 into 2 is 4, that is equal to 0. That means when we give the value of 2, that means P of 2, when we find out the value of P of 2, the polynomial value tends to 0, that means 2 is the zeroth value of the polynomial, that means zeros of the polynomial. Then 0, we will find out P of 0. P of 0 is equal to 0 square minus 2 into 0. 0 square is 0, minus 2 into 0 is 0. 0 minus 0 is 0. These two are, that means 2 and zeros are zeros of the polynomial. 2 and zeros are zeros of the polynomial. So that's why if we find out the value of a particular polynomial, and if the value of the polynomial tends to 0 for a particular value, then that particular value is called the zeros of the polynomial. That particular value is called the zeros of the polynomial. So next one, we want to find out the values of a polynomial. P of x is equal to 5x minus 4x square plus 3 at x equal to 0, at x equal to minus 1, at x equal to 2. So one by one we will find. So first we want to find out P of 0. In place of x we will give 0. 5 into 0 minus 4 into 0 square plus 3. 5 into 0 is 0. Minus 4 into 0 square is 0. That is 4 into 0 is 0 plus 3. So the value is P of 0 is 3. Then so from this it will be a hint provided that for any polynomial, if we inserted the value 0, it may or may not become 0. There will be no compulsory condition that it will become 0. It may or may not become 0. Here the value is 3, that means it is not equal to 0. So the next one is P of minus 1 we want to find. P of minus 1 equal 5 into 1. In place of x we will give 1 minus 4 into 1 square plus 3. 5 into 1 is 5 minus 4 into 1 square is 4 plus 3. That is 5 minus 4 is 1 plus 3 is equal to. Then we want to find out P of x equal to 2. That is P of 2 equal 5 into 2 minus 4 into 2 square plus 3. That is 5 into 2 is 10 minus 4 into 2 square is 4 plus 3. That is 10 minus 16 plus 3. That is 13 minus 16, that is equal to minus 3. 13, how will you get 13? 10 plus 3 is 13, then minus 16. That is minus 3. So this is the answer for that question. The next one is so we want to find zeros of the polynomial. Find zeros of the polynomial x plus 5, x minus 5 and 2x plus 5. We want to find out the zeros of the polynomial. How will you find the zeros of the polynomial? For a particular number, if the value of the polynomial tends to 0, that particular number is the zeros of the polynomial. So first of all, we want to find out p of x equal x plus 5. For what value this polynomial tends to 0? Here is 5. If this x is minus 5, then minus 5 plus 5 is 0. That means that we want to find out p of minus 5. That means x equal to minus 5 plus 5. That is equal to 0. So the zeros of the polynomial, this zeros of the polynomial is minus 5. So that means when minus 5 is inserted in the place of x, then the value of the polynomial tends to 0. So this is the zero of the polynomial. Then x minus 5. This is question number 1. So this is 1, this is 2, and this is 3. So what about question number 2? P of x equal x minus 5. So which means that this is minus 5. If the x is 5, then 5 minus 5 is equal to 0. So how will you find the 0? So P of 5 equal 5 minus 5 equal 0. That means that 5 is the 0 of the polynomial. Then third one is 2x plus 5. That means P of x equal 2x plus 5. So how will you find out the zeros of the polynomial? This is not difficult, this is simple, but with respect to this question, this is a difficult question. So 2 into x plus 5. So if here it is minus 5, in place of 2x, there will be minus 5, then minus 5 plus 5 is equal to 0. How will you find out the minus 5? So minus 5, there will be two methods. So if x is 2.5, then 2.5 into 2, 5. 5 plus 5 is equal to, so minus 5. So if the x is minus 2.5, then minus 2.5 into 2 is minus 5. Minus plus 5 is equal to 0. Then that value is the zeros of the polynomial, we can say. So P of minus 2 plus 5, that is equal to 2 into minus 2.5 plus 5. That is minus 2.5 into 2 is minus 5 plus 5 is equal to 0. So minus 2.5 is the zeros of the this polynomial. So otherwise minus 2.5 can be written in the format minus 5 by 2, no problem. Minus 5 by 2 is also minus 2.5. So this is the method of finding the value of a polynomial. Now there will be another topic called the remainder theorem and factorization method. So we will discuss in the next topic remainder theorem and factorization method in the as a next topic. So this is the method of finding the values of different polynomials. So moving to the next topic called remainder theorem. So before moving to remainder theorem, we want to know that how will you divide two polynomials. So here I show some examples of the division. So the first example is 3x square plus x minus 1 divided by x plus 1. So first what will we do? First take the first term of the polynomial. First term of the polynomial is 3x square. That is divided by x, not x plus 1. 3x square is divided by x, and write it here as the quotient. So What about 3x square divided by x? 3x square divided by x is 3x. How will you got 3x square? How will you write? 3 into x is 3x square divided by x means this x and this x cancel. 3 into x is 3x. Now, multiplying this 3x into x and write it here. 3x into x is 3x square. 3x into 1 and write it here. 3x into 1 is plus 3x. So, here we have to subtract these two. These two we want to subtract. Okay. So, before going for subtraction, just change the sign. Here is plus, therefore give minus. Here is plus, give minus. And then add 3x square plus minus 3x square is 0. X plus minus 3x is minus 2x. The balance is minus 1. Right. Again the same procedure. Minus 2x divided by x is minus 2. Right. How will you got? Minus 2x is minus 2 into x by x means x and x cancel. Then the balance is minus 2. Write it in the quotient. And minus 2 is multiplied with x and write it here. Minus 2 into x is minus 2x. Minus 2 into plus 1 is minus 2. So, just change the sign. This is minus. Plus, minus, plus. Minus 2x plus 2x is 0. Minus 1 plus 2 is plus 1. That means 1 is the remainder here. 1 is the remainder. So, this is the dividend. This is the divisor. This is the quotient and this is the remainder. How to check whether this is correct or not? We know that divisor equal, sorry, dividend equal divisor into quotient plus remainder. We will check it. So we will multiply divisor into quotient and then add remainder. If you got this value, then this will be correct. So what about the divisor? X plus 1. What about the quotient? 3x minus 2. So what about the remainder? Plus 1. So multiply x into 3x is 3x square. X into minus 2 is minus 2x. 1 into 3x is plus 3x. 1 into minus 2 is minus 2 plus 1. So this will change as 3x square. Minus 2x plus 3x is plus x. Minus 2 plus 1 is minus 1. So this is the correct answer. So how can we write this? We can write this as dividend equal 3x square plus x minus 1 equal, what about divisor? X plus 1 into 3x minus 2 into plus 1. So this is the answer. So this is the first example. Then we have to move the second example. Now x cube plus 1 divided by x plus 1. First step, x cube divided by x is x square. Correct? How will you write x cube? X into x by x. X and x cancel. X into x is x square. So again, x square into x, that is x cube. X square into 1, that is plus x square. So write it here. X cube, we have to change the sign. X cube here is minus. Here is also minus. X cube minus x cube is 0. Here there will be no x square terms in the dividend. So consider it as 0. 0 minus x square is minus x square. Then the remainder, the balance one is plus 1. Correct? So minus x square divided by x. Minus x square divided by x is minus x. So minus x square, how will you write? Minus x into x divided by x. X and x cancel, the balance is minus x. So minus x into x is minus x square. Minus x into 1, that is minus x. Here, change the sign. So here is plus, here is plus. So x square minus x square plus x square is 0. Here there will be no x term here, so consider it as 0. 0 plus x is plus x, balance is plus 1. Okay, then again the same procedure. X divided by x is 1 plus 1. 1 into x is x, 1 into 1 is plus 1. So the thing is that minus x is 0, 1 minus 1 is, so the remainder is 0. So please check, or otherwise we have to check that divisor is x plus 1 into quotient, that is x square minus x plus 1. If this 2 multiplies, we got the answer x cube plus 1, then that will be correct. The remainder is 0, so there will be no addition of remainder, that is equal to, which changes to x into x square, x cube, x into minus x square, x into plus 1 plus x, 1 into x square plus x square, 1 into minus x, 1 into 1 plus 1. Which all the terms cancel? What all the terms cancel? X square minus x square cancel, x minus x cancel, and the final answer is x cube plus 1. And this is the right answer. So how will you write x cube plus 1? X cube plus 1 equal x square minus x plus 1 into x plus 1. So this is correct. So the third one, so here is the polynomial, first one, here is the polynomial, 3x square, first one, 3x square plus x minus 1, and which is divisible by x plus 1, and the remainder is equal to 1. We already find out the remainder is 1. So there will be a shortcut. So this is a polynomial p of x. If p of x is divided by x minus a, then p of a is the remainder. P of a is the remainder. We can check. So by long division method, we find that the remainder is 1. So if 3x square, p of x equal 3x square plus x minus 1, then it is divided by x minus a, then p of a is the remainder. So if a quantity is p of x, that is not my quantity, it is polynomial. Polynomial is divided by x minus a, then p of a is the remainder. How will you find p of a? So x plus 1 is here. So 3x square plus x minus 1 is divisible by x plus 1 is the factor we want to divide. So if the remainder is, according to the theorem, the remainder is p of minus 1. So how will you find? P of minus 1 equal 3 into minus 1 the whole square plus minus 1 minus 1. 3 into minus 1 the whole square equal 1 plus minus 1 is minus 2. 3 into 1 equal 3 plus into minus 2. 3 minus 2 equal to 1. So by long division method we got the answer as 1, and also by using this principle the answer is also 1. So we can use the principle as a shortcut method. So the next one we found that the remainder is 0. The remainder is 0. Here x cube plus 1 is divided by x plus 1. The remainder is 0. That means that we will check it out. That p of x equal x cube plus 1. Then already we find out that the remainder is equal to 0. According to the theorem, p of x is divided by x minus a, then p of a is the remainder. So that is divided by x plus 1, divided by x plus 1. Then p of minus 1 is the remainder. P of minus 1 is the remainder. Then p of minus 1 equal x cube minus 1 the whole cube plus 1. What about minus 1 the whole cube is minus 1. If minus 1 the whole square is 1. Minus 1 the whole cube is minus 1 plus 1. That is equal to 0. So the remainder is. So next one more problem is added. Okay. One more problem is that x cube plus 3x square plus 3x plus 1 could be divided by x plus 1. X plus 1. So how will you find the remainder? So this is x plus 1. So x cube divided by x is, what about x square? X square into x, x cube, x square into 1 plus x square. So this is minus, x cube minus x cube 0, 3x square minus x square is 2x square plus 3x. So 2x square divided by x is plus 2x. 2x into x is 2x square. 2x into 1 is plus 2x. So minus minus. This one is 0. 3x minus 2x is 1x. 1x plus 1. 1x divided by x is 1 plus 1. 1 into x is 1x. 1 into 1 is plus 1. This one minus, this one minus. So the remainder is 0. The remainder is 0. That means x plus 1. So p of x equal x square plus 2x plus 1. Then there, which is divided by x plus 1. Then p of minus 1 is the remainder. P of minus 1 is the remainder. Okay. Then it will indicate that p of minus 1 is equal to 0. As we already know that by long division method, the remainder is 0. So p of minus 1 is also 0. So p of minus 1 equal, we will check. P of minus 1 equal minus 1 the whole square plus 2 into minus 1 plus 1. Minus 1 the whole square is 1 plus 2 into minus 1 is minus 2 plus 1. 1 plus 1 is 2. 2 plus minus 2. That is equal to. So that is the remainder theorem. In general, we can show the remainder theorem as, we can give the explanation for remainder theorem as if p of x divided by x minus a, then p of a is the remainder. Also, p of x divided by x plus a, then p of minus a is the remainder. This is simply the remainder. So moving to the next topic called factor theorem. factor theorem. So we will give the conclusion of factor theorem after the examples are done. So first of all, we want to know that. So I will give an example. Check whether check whether check whether x plus 2 is a factor of x cube plus 3x square plus 5x plus 6. So given p of x is equal to p of x equal x cube plus 3x square plus 5x plus 6, which means that given that the polynomial p of x is equal to 3x cube plus 3x square plus 5x plus 6. So we want to check whether that is x plus 2 a factor. How will you find? As we know that according to the concept of remainder theorem, if x plus 2 is divisible by, or this is a polynomial and we want to divide that polynomial by x plus 2. So according to the concept of remainder theorem, the remainder of the polynomial is p of minus 2. So x plus 2 is the divisor, and we got the remainder by taking the value of p of minus 2 according to the concept of remainder theorem. If p of minus 2 equals 0, then we can say that the remainder is 0. When the remainder is 0, it is a factor. That means that first of all we have to apply the remainder theorem such that we want to find out p of minus 2. P of minus 2 equal minus 2 cube plus 3 into minus 2 the whole square plus 5 into minus 2 plus 6. That is minus 2 the whole cube is minus 8 plus 3 into minus 2 the whole square is 4 plus 5 into minus 2 is minus 10 plus 6. So minus 8 plus 4 into 3 is 12 plus minus 10 plus 6. What are the positive terms are there? There will be 2 negative terms and 2 positive terms. Minus 8 plus minus 10 is minus 18 plus 12 plus 6 is 18. Minus 18 plus 18 is equal to 0. That means that p of minus 2 is 0, which means that the remainder of that one is 0. When the remainder is 0, that one is a factor. That means that x plus 2 is a factor of, x plus 2 is a factor of this polynomial. X plus 2 is a factor of this polynomial. Okay, x plus 2 is a factor of this polynomial. Next one. Next one. 2x plus 2. Check. Check. This is the polynomial p of x. Check. And the factor is x plus 2. We want to check that x plus 2 is a factor of 2x plus 2. Check x plus 2 is a factor of 2x plus 2. That is, given p of x equal 2x plus 2. So what about, we want to check that x plus 2 is a factor. If x plus 2 is a factor, then according to the remainder theorem, the remainder is 0. So how will you find the remainder? P of minus 2. If p of minus 2 equals 0, then x plus 2 is a factor. If p of minus 2 not equal to 0, then x plus 2 is not a factor. So we want to check. So what about p of minus 2? P of minus 2 equal, p of minus 2 equal, p of x is equal to 2x plus 2. Minus 2 equal 2 into x equal minus 2 plus 2. That is 2 into minus 2 equal minus 4 plus 2. That is equal to minus 2. That is P of minus 2 equal minus 2, which is not equal to 0. That means that x plus 2 is not a factor. X plus 2 is not a factor. Check whether x plus 2 is a factor of 2x plus 2. P of x is equal to 2x plus 2. Then P of minus 2 is equal to 0. Then if P of minus 2 is equal to 0, if P of minus 2 is equal to 0, then x plus 2 is a factor. If P of minus 2 is not equal to 0, then x plus 2 is not a factor. That means that here x plus 2 is not a factor. So what about the next question? The next one is P of x equal x cube plus x square plus x plus 1. We want to check whether x plus 1 is a factor or not. X plus 1 is a factor. To find out x plus 1 is a factor or not, we first find out P of minus 1. P of minus 1 equal minus 1 the whole cube plus minus 1 the whole square plus minus 1 plus 1. That is minus 1 the whole cube means minus 1 plus minus 1 the whole square means 1 plus minus 1 plus 1. That is minus 1 plus minus 1 is minus 2. 1 plus 1 is plus 2. Minus 2 plus 2 is 0. That means that x plus 1 is a factor. X plus 1 is a factor of P of x. And the last question is P of x equal x raised to 4 plus x cube plus x square plus x plus 1. We want to check whether x plus 1 is a factor. If x plus 1 is a factor, then P of minus 1 is equal to 0. P of minus 1 equal minus 1 the whole raised to 4 plus minus 1 the whole raised to 3 plus minus 1 the whole raised to 2 plus minus 1 plus 1. Minus 1 the whole raised to 4 is 1 plus minus 1 the whole raised to cube is minus 1 plus minus 1 the whole raised to square is 1 plus minus 1 plus 1. That is 1 plus 1 plus 1 is 3. Minus 1 plus minus 1 is minus 2. 3 minus 2 is 1. So x plus 1 is not a factor of this one. So how will you find out is the polynomial given expression or given polynomial is a factor of P of x? So this is the method to find out is it a factor or not. First of all, you have to find out the remainder. If the remainder is 0, then it is a factor. If the remainder is not equal to 0, then it is not a factor. So what about factor theorem? That means if P of x is given by something like that 3x square plus 4x cube plus 5x like that. So generally we have to mention that P of x. So if P of A equal 0 for some polynomials, say P of x, or otherwise we can say that if we consider the polynomial, if we consider the polynomial P of x, if we consider the polynomial P of x, not if consider the polynomial P of x, if P of A equals 0, then x minus a is a factor. This is simple. So for the polynomial p of x, if p of x a is equal to 0, for the if the polynomial is considered such that previous examples like x cube plus 3x square plus 5x plus 6 or 2x plus 2 or x cube plus x square plus 1 like that. If we consider a polynomial and in that polynomial if p of a is equal to 0, then x minus a is a factor of the polynomial, reverse of the remainder theorem. Simple. So how will you find out the given factor or the given polynomial is a factor of the polynomial p of x? So first of all, you have to find out the remainder by using the remainder theorem. And if the remainder is 0, then it is a factor. And if the remainder is not 0, then it is not a factor. That's all about the factor theorem. So moving to some more problems related to polynomials. So the first problem is that we want to factorize y square minus 5y plus 6. How will you factorize this? So there will be two methods to factorize. One, we can use the factor theorem, and the other one we can use the middle term splitting. First I use the middle term splitting. So we want to split the middle term. So to split the middle term, there will be some condition regarding that. So if y square minus 5y plus 6, so the middle term is 5y and the last one is 6. If we take two numbers such that there will be two factors such that y minus a and y minus b are the factors. Okay, y minus a and y minus b are the factors. Now we got ab is equal to 6. We want to find out two numbers and the numbers should satisfy the condition such that ab is equal to 6 and a plus b equal to minus 5. So we want to find out two numbers in such a way that if that two numbers are multiplied, we got the value as 6. If that two numbers are added, we got the value as minus 5. So we want to find out those two numbers. So what are those two numbers? If we take minus 3 and minus 2, then minus 3 into minus 2 is 6. Okay. Minus 3 plus minus 2 is minus 5. Okay. So these two conditions satisfied. So A is minus 3 and B is minus 2. So we can take minus 3 and minus 2. Minus 3 and minus 2. So we have to use that one, the middle term splitting. Y square minus 3y minus 2y plus 6. Correct? So you have to change that equation to condition 2. Then y square minus 3y. So we can take y as the common factor. Y into y minus 3. So y into y minus 3 means y into y square, y into minus 3 minus 3y. Then minus here what is the common factor? 2 is the common factor. Minus 2 is the common factor. We can use y minus 3. So y minus 3 minus 2 into y minus 3. So minus 2 into y minus 2y minus 2 into minus 3 plus 6. It's okay. So the first factor is inside the bracket. You check inside the bracket, the first factor is situating inside the bracket, that is y minus 3. Here also y minus 3. You have to took only one y minus 3. Inside bracket, the first factor we got. Second factor is the remaining one. Second factor, remaining one. So what about the first factor? First factor is y minus 3. So y minus 3 is the first factor and y minus 2. The balance is y minus 2. Y minus 2 is the second factor. So we can write y square minus 5y plus 6 equal y minus 3 into y minus 2. This is the first method called middle term splitting. We can use the factorization method also into this method. It is so simple, the factorization method, such that we can calculate the factorization method by using the following technique. We use a small technique to find out the factorization method such that this is the polynomial y square minus 5y plus 6. If we directly factorize, so the factorization method, you have to assure that the coefficient of y square will be 1. The coefficient of y square will be 1. Then you have to factorize. Otherwise, you have to make the coefficient of y square or x square the equation to 1. So here the y square, the coefficient of y square is 1, we have to use the factorization method. So for the factorization, such that we have to analyze that there will be two numbers we have to take, such that if that two numbers are added, we got minus 5, and that two numbers are, if a plus b is equal to minus 5 and ab is equal to 6. What are the two numbers? That two numbers are minus 3 and minus 2. So the factors are x minus 3, sorry, y minus 3, y in terms of y minus 3 and y minus 2 are the factors. We can directly find out from this equation. Y minus 3 and y minus 2 are the factors. So y minus 3 and y minus 2 are the factors. So we can write y square minus 5y plus 6 equal y minus 3 and y minus 2 into y minus 2. Correct. So this is the method. So this is the method of middle time splitting and factorization. We can use another equation. We will use another one. So another example is that 6x square plus 17x plus 5. So look at the coefficient of x square. X square, the coefficient is 6. By using the middle term splitting, we have to choose two terms, two numbers, such that the addition, that is a plus b is equal to 17 and ab is equal to, almost all one says 5. No, it is not 5 because their coefficient is 6. So 6 into 5 is 30. So we have to choose two numbers in such a way that there will be a plus b is equal to 17 and ab is equal to 30. So what are the two numbers? 15 and 2. So 15 plus 2 is 17, right? 15 into 2 is 30. We have to split the middle term. We have to split the middle term such a way that 6x square plus 15x plus 2x plus 5. So what are the common terms here? How can we take the common term? So otherwise we have to check that, not right this way. 6x square plus 2x plus 15x plus 5, like that we can write. So what is the common term here? 2x we can take as common term. 2x into 3x plus 1, right? So 2x into 3x is 3 into 2, 6, x into x square, 6x square, plus 2x into 1 is 2x, right? It's completed, plus inside the bracket we want 3x plus 1, that's we know. So what is the common term here? 3. No, it will be taken as 5. 5 into 3x plus 1, that is 5 into 3x is 15x, 5 into 1 is 5. So inside the bracket, first factor is just situating inside the bracket, that is 3x plus 1. Second one is, what is the second one? Second one is 2x plus 5. 2x plus 5. So we can write 6x square plus 17x plus 5 equal 3x plus 1 into 2x plus 5. These are the two factors. So we can use also the factorization method. By using the factorization method, you have to convert this coefficient into 1 So how will you convert the coefficient to 1? You have to divide the whole equation by 6. Then the coefficient will be x square plus 17 by 6 plus 5. 5 by 6. So then you have to apply that method. AB is equal to 17 and a plus b is equal to 17 by 6 and AB is equal to 5 by 6. Then that way you can factorize also. So this is the method of factorization. We can use another polynomial to factorize. We can use another polynomial to factorize. That is, the next one is x cube minus 23x square plus 142x minus 120. Okay. So how will you find the factor? So we want to factorize this one, this polynomial. How will you find the factors of the polynomial? So this is not a second degree equation. As we know that this is a third degree equation. So for the third degree equation, first of all, we want to find out a one factor from this one. Then we have to do the next steps. So first of all, so what are the factors of 120 we analyze? 1 is a factor of 120, 2 is a factor of 120 because 2 into 60 is 120, 3 is a factor of 120 because 3 into 40 is 120, 4 is a factor of 120, that is 4 into 30 is 120, 20 is also a factor, that is 20 into 6, like that 1, 2, 3, 4, 5, 6, so many factors. So we have to put, first of all, we will write this as P of x is equal to x cube minus 23x square plus 142x minus 120. So first of all, we have to find out P of 1. If P of 1 is 0, according to the remainder theorem, if P of 1 is 0, then x minus 1 is a factor. If P of minus 1 is 0, then P of minus 1 is 0, then x plus 1 is a factor. If P of 2 is 0, then x minus 2 is a factor. If P of minus 2 is 0, then x plus 2 is a factor. So that's why we have to use some trial and error method and we have to find out only one factor from this one. So P of 1, how will you find P of 1? 1 cube minus 23 into 1 square plus 142 into 1 minus 120. So 1 cube is 1 minus 23 into 1 square is 23 plus 142. 142 into 1 is 142 minus 120. So 1 minus 23 is minus 22 plus 142 minus 120. So minus 22 plus minus 120 is minus 142 plus 142. That is equal to 0. That means P of 1 is 0. According to remainder theorem, P of 1 is 0. Then x minus 1 is a factor. So the first factor already we find. That is x minus 1 is a factor. X minus 1 is a factor of P of x. Because what is the reason? Because P of 1 is equal to 0. That's the reason. So we have to divide this polynomial with this factor. We got a quadratic equation, and from that quadratic equation, by splitting the middle terms, we found another two factors. Okay, so the polynomial is x cube minus 23x square plus 142x minus 120. The whole divided by x minus 1. So how will you divide? X cube by x is x square. X square into x is x cube. X square into minus 1 is minus x square. So x cube, this one is minus, this one is plus 0. 23x square plus x square is minus 22x square plus 142x. Minus 22x square divided by x is minus 22x minus 22x. Minus 22x into x minus 22x square. Minus 22x into minus 1 plus 22x. So this is plus, this is minus. This one is 0. This one is 142 minus 22 is 120 plus 120 plus 120 x minus 120. 120x divided by x is plus 120. 120 into x is 120x. 120 into minus 1 is minus 120. So this one is minus, this one is plus. 120x minus 120x 0, minus 120 plus 120 is 0. So the quadratic equation we got is x square minus 22x plus 120. So we have to factorize this one. How will you factorize this one? So we have to take two numbers in such a way that if we add that two numbers, a plus b is equal to minus 22, and if we multiply that two numbers, ab is equal to 120. This is the condition. We have to take a and b in such a way that if that two numbers are added, we got minus 22. If that two numbers are multiplied, we got 120. So this is the condition for taking the numbers. So how will you take the number? So the numbers are minus 10 and minus 12, right? Minus 10 plus minus 12 is minus 120, minus 22. Minus 10 into minus 12 is plus 120, right? So what are the factors? X minus 10 and x minus 12 are the factors. So there will be three factors are there, that is x minus 1, x minus 10 and x minus 12. So how will you write? X cube minus 23x square plus 142x minus 120 can be written as x minus 1 into x minus 10 into x minus 2. So these are the method of factorizing a polynomial. These are the method of factorizing a polynomial. So moving to the topic identities. This is the last portion of the chapter, identities. So here we will we already write four identities. Such that what are the identities? First one is a plus b the whole square. What is the expanded form of a plus b the whole square? A square plus 2ab plus b square. So this is an expanded form. So we have to bifurcate this all the identities. So the next one is a minus b the whole square. What about a minus b the whole square? A square minus 2ab plus b square. What about a square minus b square? A square minus b square is equal to a plus b into a minus b. And what about x plus a into x plus b? X plus a into x plus b is x square plus a plus b into x plus ab. X plus a into x plus b is equal to x square plus a plus b into x plus ab. So these are the four identities. Using the identities, we can use some problems. We can solve some problems related to that identities. So these are the first four identities given in the chapter. So the first identity is a plus b the whole square, that is a square plus 2ab plus b square, a minus b the whole square, a square minus 2ab plus b square, a square minus b square, that is a plus b into a minus b, x plus a into x plus b is equal to x square plus a plus b into x plus ab. So how will you solve? So I will write just so y plus 3 the whole square. How will you expand y plus 3 the whole square? So this is in the format a plus b the whole square. How will you expand? That is y square plus 2ab. That means 2 into y into 3 plus 3 square. That is y square plus 2y into 3. That is 2 into 3, 6y plus 9. This is the expanded form. Using the identity 1. What about a minus b the whole square? Y minus 3 the whole square. How will you write y minus 3 the whole square? That is a minus b the whole square is a square minus 2ab plus b square. That is y square minus 2 into y into 3 plus 3 the whole square. That is y square minus 6y plus 9. What about a square minus b square? A square minus b square, we can write x square minus y square. How will you write x square minus y square? X plus y into x minus. This is the equation. X square minus y square is equal to x plus y into x minus y. A square minus b square. Also, we can do these problems. The first two problems are related to identities. The first problem is find the product x plus 3 into x plus 3. X plus 3 into x plus 3. Find the product x plus 3 into x plus 3. How can you find? This x plus 3 into x plus 3 can be in the format, we can change it into x plus 3 the whole square. Okay, so what about the format? X plus 3 the whole square is a plus b the whole square. A plus b the whole square is a square plus 2ab plus b square. That is x plus 3 the whole square is equal to x square plus 2 into x into 3 plus 3 square. That is x square plus 2 into 3, 6x plus 9. So this is the product of x plus 3 the whole square. What about the second problem? Find out the product of x minus 3 into x plus y. First of all, you have to find that which identity this is. What about this is the identity x plus a into x plus b. That is here a is equal to minus 3 and b is equal to 5. Okay, so we can elaborate x minus 3 into x plus 5 in a way that is equal to x square. X square. X square will write then plus a plus b. A plus b. What about a? Minus 3 plus b is 5 into x plus ab. What about a and b? Minus 3 into 5. We can use x square plus minus 5 plus 3 is 2x plus minus 15. 2x plus minus 15, which can be written as x square plus 2x minus 50. This is the product. So minus 3 plus 5 means 2. 2 into x is 2x. 2x plus minus 3 into 5 is minus 15. That is plus into minus is minus 15. So this is the way we have to find the product. So next one is, third problem is factorize 49a square plus 70ab plus 25b square. Okay, so how will you factorize? How will you write? 49a square is written in the format 7a the whole square. Okay, what about 25b square? 25b square can be written as 5b the whole square. So here a is 7a. A equal 7a and b equal 5b. This can be written in the format a plus b the whole square. How will you write in the a plus b the whole square format? That is 7a 7a the whole square plus 2ab. 2 into 7a into 5b plus 5b the whole square. That is 7a the whole square plus 7a the whole square means 49a square, 49a square plus 2 into 7, 14 into 5, 70eb plus 25b square. So this can be written as in the format, which format? A plus b the whole square. It is right. What about a? 7a plus what about b? 5b the whole square. So what are the factors? 7a plus 5b into 7a plus 5. These are the factors. So these can the examples of first four identities. Next we are moving to the next four identities. So moving to the fifth identity, it itself in the board such that the fifth identity is that a plus b plus c the whole square equal a square plus b square plus c square plus 2ab plus 2bc plus 2ac. Already we know the identity such that a plus b the whole square such that a square plus 2ab plus b square. So right now here is not a plus b the whole square, it is a plus b plus c. There will be three times here in the identity. A plus b plus c the whole square is a square plus b square plus c square plus 2ab plus 2bc plus 2ac. So with respect to that identity, we can run a problem such that there is a question regarding identity 5 such that there is 3a plus 4b plus 5c the whole square. We have to expand this one. So expand, this is the question. Expand 3a plus 3a plus 4b plus 5c the whole square. So we want to expand this one. 3a plus 4b plus 5c the whole square. What about the identity a plus b plus c the whole square? What is a here? A is 3a, b is 4b, and c is 5c. Here a 3a 4b 4b, in place of it is not equal. In place of a we have to place 3a, in place of b we have to place 4b, in place of c we have to place 5c. So this is the identity. 3 a plus b plus c the whole square equal a square plus b square plus c square plus 2ab plus 2bc plus 2ac. With respect to that identity we can expand this one. So what about 3a plus 4b plus 5c the whole square equal, that is a square. What is a square? 3a the whole square plus b square. What is b square? 4b the whole square plus c square. What is c? 5c the whole square plus 2ab. 2 into what is a? 3a into what is b? 4b plus 2bc. 2 into what about b? 4b into what about c? Into 5c plus 2ac. 2 into what about a? 3a into what about c? 5c. That is equal to what about 3a the whole square? 3 square is 9. 9a square plus what about 4b the whole square? 4 square is 16. 16b square plus what about 5c the whole square? 25c square plus 2 into 3a into 4b, that is 4 into 3 12, 12 into 2 24 ab plus what about 2 into 4 into 5, 5 into 4 20, 20 into 2 40 bc plus 3 into 5 15, 15 into 2 30, 30 ac. So this is the expanded form of 3a plus 4b plus 5c the whole square, that is equal to 9a square plus 16b square plus 25c square plus 24ab plus 40bc plus 30ac. So that's all about identity 5. Now moving to identity 6. We want to move to identity 6. What is identity 6? Identity 6 is that a plus b the whole cube equal a cube plus 3a square b plus 3ab square plus b cube. So that is identity 6. A plus b the whole cube equal a cube plus 3a square b plus 3ab square plus b cube. So with respect to that identity we can do the problem like with respect to that identity we can solve this problem, that is expand 3a plus 3a plus 4b the whole cube, 3a plus 4b the whole cube. So here in place of a that is 3a, in place of b that is 4b, so 3a plus 4b the whole cube. So what about 3a plus 4b the whole cube? The identity itself shows that a cube. Here in place of a that is 3a, 3a the whole cube plus 3a square b, that is 3 into what is a square? 3a the whole square into what is b? 4b plus 3ab square. 3 into what is a? 3a into what is b? 4b the whole square. So 3ab square plus b cube. B cube is 4b the whole cube. Just check. A cube 3a the whole cube plus 3a square b. 3 into in place of a, that is 3a. 3a the whole square into b 4b plus 3ab square. 3 into a is 3a into b square is 4b the whole square plus b cube. So that is equal to what is 3 cube? 27 a cube plus 3 into 3 9. 9 into 4 36. 36 a square b plus 3 into 3 9. 9 into 4 36. 36 ab square. 36 a square. 3 into 3 9. 9 into 4 36. 36, that is, no, here there is a mistake regarding that. You have to open the bracket itself. So here is 27 a cube plus 3 into what is 3 square? 9. 9 into what is a square? 9 a square into 4b plus 3 into 3a into what about 4 square? 16. 16b square plus 4b cube. 4b cube means 4b the whole cube means 4 cube is 64. 4 into 4 into 4. 16 into 4 is 64 b cube. That is equal to 27 a cube plus 9 into 3 27. 27 into 4 20 into 4 18. 7 into 4 28. That is 108. 108 a square b plus 3 into 3 9. 16 into 9. What about 16 into 9 is 144. 48. 16 into 3 48. 48 into 3 is 144. 144 ab square. ab square plus 64 b cube. This is the expansion. So what about 3a plus 4b the whole cube is 27a cube plus 108 a square b plus 144 ab square plus 64 b cube. That's all about sixth identity. What seventh identity? Seventh identity is a minus b the whole cube. A minus b the whole cube is same as that of a plus b the whole cube. There will be a slight change regarding the signs. So alternate plus and minus signs given in a minus b cube. A minus b cube is a cube minus 3a square b plus 3ab square minus b cube, like that. So with respect to that identity, we can do that problem. 5p minus expand 5p minus 3q the whole cube. Here a is 5p, b is 3q. So a minus b the whole cube is a cube minus 3a square b plus 3ab square minus b cube. So 5p minus 3q the whole cube equal. First of all, a cube. A cube is 5p the whole cube minus 3a square b. 3 into what is a? 5p the whole square into what is b? 3q plus 3ab square. 3 into what about a? 5p into what about b? 3q the whole square plus b cube. 3q the whole cube, not minus b cube. Alternate plus and minus signs are there. So minus b cube. That is equal to 5 cube is 125. 5 into 5 into 5. That is 125 p cube minus 3 into what about 5 square is 25 p square into 3 cube plus 3 into 5. That is 3 into 5p into what about 3 square? 9q square minus 3 cube is 27q cube. That is equal to 125 pq minus 3 into 25, 75. 75 into 3. What about 75 into 3? 70 into 3, 210, 5 into 3, 15. That is 225. 225. 25 into 3 Is it right? Right. 3 into 5p, the whole square is 5 square is 25 p square into 3q. That is 3 into 3, 9. 25 into 9 is 225 p square q plus 9 into 3, 27 into 5. 27 into 5 is 135, right? 135 p q square minus 27 qq. So 125 pq minus 225 p square q plus 135 pq square minus 27 qq. So this is the answer for question number 3. That is a minus b the whole cube format, 5p minus 3q the whole cube. So moving to the last one, last identity. The last identity is a cube plus b cube plus c cube minus 3abc equal a cube plus b cube plus c cube minus 3abc. The result is a plus b plus c into a square plus b square plus c square minus ab minus bc minus ac. So we can factorize. We want factorize 8x cube plus y cube plus 27z cube minus 18xyz. So how can we write this one? We can write 8x cube in the format 2x the whole cube, right? That is 2 cube is 8, x cube is x cube. So 8x cube plus y the whole cube, that is y cube, plus what about 27? 27 is 3 is that the whole cube. Is it right? Right. Because 3 cube is 27, z cube is z cube. So this is a and this is b. This is b, this is a, this is b, and this is c. So minus, this can be written in the format 3 into 2x into y into 3z. Is it right? 2 into 3, 6, 6 into 3, 18. 18xyz. Correct. That is 8x cube plus y cube plus 27z cube minus 18xyz, which can be written in the format 2x the whole cube plus y cube plus 3z the whole cube minus 3 into 2x into y into 3z. So we can open or we can expand using this identity. This can be written in the format. This is in the format a cube plus b cube plus c cube minus 3abc, where a is, what about a? A is 2x. What about b? B is y. What about c? C is 3z. So this can be written in the format. Which format? A plus b plus c. A plus b plus c is a is 2x plus b is y plus c is 3z. A plus b plus c into a square plus b square plus c square. What is a square? A square is 2x the whole square plus what about b square? Y square plus what about c square? 3z the whole square minus ab. We want ab. What about ab? Ab is 2x into y. 2xy minus what about bc? What about bc? Y into 3z. Y into 3z minus ac. 2x into 3z. 2x into 3z. So this can be changed as 2x plus y plus 3z into what about 2x the whole square, that is 4x square plus y square plus 9z the whole square. Sorry, 3z the whole square is 9z square minus 2xy minus 3yz minus 6xz. So this is the factorization, and that's all about the problem number 4 and identity 8. So all the examples are related to identity 5, 6, 7 and 8 respectively, and all the problems are right now solved. This is all about the chapter polynomial. In the polynomial, we already studied about what is remainder theorem, how to factorize, and all these identities related to that. And we already solved 10 to 15 problems regarding in this chapter. So these are all the main topics related to the chapter. So that's all about the chapter polynomial. And I am Sudhi here signing off from the chapter, and we will let you see in the next chapter with another topic or another portion. Thank you for joining me the class, and see you.